So solar energy, renewable. Here's my map. Obviously, you want to put solar panels where there's a lot of sun. Alaska, not one place to use solar energy. Well, when there could be 11 hours without sun, so I don't think that's going to work too well. So, solar has two main types: passive and active. And the main difference is active has a system or some kind of, you know, I guess it's a system, some kind of functioning property to it, where passive is just like direct flow of solar energy. And we're going to focus a little bit on active because passive, again, you use the energy. It has no system, and it's mainly dealing with heat. So when you use sun to produce heat without any kind of system, it's passive solar energy.
Is that like when your car gets really hot?
Sure. So a heating system in the end. And there's a picture of the sun coming in and the heat, and I guess it's using it to spin the fan in some way. Solar cells, well, they're considered already some kind of system, unless if you just put solar cells to heat a pool, that's still kind of passive. But when a system is involved, so there's a flow of electrons or some kind of battery or some kind of energy store, then it's active. And examples of active are when you use panels, mirrors, you use heat collectors or fluid systems that transfer heat. And you also use it for heating, but a lot of the active solar systems are for electricity production. So heating can also be an active system. So solar panels, if you put one of the advantages to solar energy is you can put them directly on your home, and that's just a sample of a home with, so obviously not the best looking example. I should update those. Solar thermal heating systems, and this is, I think, where we kind of left off yesterday. So these systems are, it's just another type of active solar example, and you have to know the different types of active solar energy. So solar thermal heating systems is one. PV cells, which are called photovoltaic cells. Something you have to know about them is that they're mainly constructed of what? Silicon, okay? You have to know that because that's a non-renewable mineral, and that's kind of like a negative, you know, a disadvantage to solar energy because we use non-renewable materials to build the PV cells. So the PV cells, sunlight comes in, there's a flow of electrons. If you see the picture on the bottom, it shows photons, and then you have an electron flow. And again, you don't have to know the full method of the transferring of electrons or how it sends the electric current, but it's the same system. You have sun, so that's solar energy to heat energy to mechanical of electrons to electrical, which is electron flow. You can use photovoltaic cells and produce a power plant, but mainly the power plants are used with some kind of heat fluid system. So you're going to take the sun and they're going to have some kind of fluid system, and I think I have a better picture to get more power generation. All right. So solar thermal power plants use the sun's rays to heat fluid. So heat transfers through the system and produces steam, and the steam is going to do what? Spin the turbine, attached to a generator, sends electric current. So same process with little efficiency, okay? Unfortunately, solar active systems have very little efficiency. Solar passive, and write this down because this is an AP test question for sure, most efficient form of heating. Solar passive. Most efficient. So there's the steam turning the turbine and electric current. Blah, blah, blah. Same process. Here's more information on the solar thermal systems. You got power tower systems, and unfortunately you have to know these vocabs. Central receiver systems, solar, like when it's talking about like the flow through. And if you look at this picture, you can see they're using mirrors to track and reflect sunlight onto a receiver, and that's where you get the system. The receiver collects the heat, and then you got some kind of fluid transfer, and that is used to make steam, and blah, blah, blah. So solar dish systems is another type of what? Let's see who's following along. Good. So just know that we're talking about solar thermal heating systems. All right, so sun is fast growing, just like we said the other day. And what's the second?
Wind.
Wind, good. And we know it's renewable. It's very, 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 very clean, other than, again, the initial installation or initial production. And yes? You see, the sun is abundant. Without the sun, there's no life on Earth, so it's going to be around as long as we exist, so it can produce energy. I would add an advantage to solar is its multi-use, because up until now, we've been talking about how to produce electricity or how to find substitutes, okay? So we talked about hydroelectric and wind, and solar is the first one that has other uses that are beneficial for our energy crisis needs, such as what? Wow. What's the energy crisis need? Can you use hydroelectric power to power your car? No. Can you use wind? In theory of not. Now wind, they have some systems for energy conservation in your car. Like there's a product called the Tornado or something, and it helps conserve gas because it uses wind power to reduce or make your car more efficient in terms of mileage, okay? But solar can substitute petroleum for transportation of your car. I think you even said, did you say that was a solar powered
That was solar
flight?
powered, right?
Except it wasn't a passenger flight, but they have a solar powered what?
Like cars.
Yeah, so first one we've talked about of the three that can actually substitute another energy need besides electricity, okay? Right, but we haven't talked about that yet in the videos. So biofuel has its own category, which makes it why I say it's one of the most important. The sun, disadvantages. Night. Now, I could say right now, and you can add this was a big disadvantage when they first introduced solar power. However, because of the backup systems, this is almost not even a disadvantage. Because if you have a backup, you're going to produce so much energy during the day that you're going to collect and you're going to be able to pay back hours to FPL. So what I was saying when you guys were presenting, solar collects so much energy, you can actually earn money from having solar power panels installed in your home. So that's an advantage. You collect so much energy during the day that you could sell back kilowatt hours. So no efficient. Look how old that is. You don't get solar panels installed in your home without an efficient backup system, and they exist. So that was an old disadvantage. Clouds. Obviously, on a really, really rainy day, you're going to collect less power, but still, you know that the sun rays still come down. So it's expensive as usual, initial cost. So that's always bad. It's also very expensive per kilowatt hour if you get sun from a solar power plant. If it's directly in your home, once you install, everything is cheaper. So if you look at the net energy, it says it's moderate for active, but it's very high for passive. You have to know that. Clean and like practically no pollution. You need access to the sun is a disadvantage. Obviously, we said that, so not everybody can use this as a alternative energy. And you need some kind of storage system in order to be successful. And you could just look through these. They're pretty much all the same when you look them up. I just put them all there. So trade-offs for solar cells, we already talked about. You're going to have an initial cost, but in the end, you're going to collect so much storage, you can actually pay. You could get paid. We did wind, so geothermal, heat within the earth. That is by definition. Examples of geothermal energy, or where we could get it from, you could get it from hot springs, geysers, hot water, and hot rocks, okay? And there's just a picture of different parts of geothermal energy. So you're looking at the geyser, you're looking at a hot spring, and you're looking at, you know, porous rock, and then just like dry rock. That's why they mentioned the dry rocks. And there's a clear picture of, your pictures were obviously way better than mine, though. You're welcome. There's another one.
What is that?
And there's a picture of the hot water and the hot rocks. So you're going into the earth to try to retain this heat. And there is a review of Earth's interior geosphere, crust, mantle, and core, and you know the heat temperature ranges within each. And this is one of the things that they kind of like said but didn't really say. And the Ring of Fire is like a key to tapping into geothermal energy. So there's some geography for you, although it's not really as specific as that, because you saw what they mentioned regarding the areas that they're tapping into. And there's just a map of where in the United States, which there's more of the U.S. resource use of geothermal energy. Now, one of the good things of geothermal, like solar, like wind, not like hydroelectric, in a sense, because you can't have some kind of water system to produce electricity in your home, but it's not really that reliable. If you build this tapping into geothermal energy directly into your home, it's for heating, but it could be linked to some kind of system, and it could generate power as well. And I think I have a diagram of, again, they did a really good job of mentioning the looping system, which none of us really understand, but here's what I want you to understand. There's two ways to use geothermal energy. You're either gonna tap into the ground's heat if you're gonna produce electricity from it. You're gonna add cold water so steam comes back at you, spins the turbine and sends the electric current, or you're gonna go straight to the steam that's being produced from geysers, okay, and do the same process. So you're gonna get to the heat by adding cold water and getting steam, or you're gonna use the steam. And this is what I was referencing that I told you guys I had. Let me pause. I know. So you guys did a good job. Other uses, you could use it for heating, and that's just a picture. Look, I actually said where it's from. A nursing home powered by geothermal energy in Australia, and they heat the pool like that. I don't know. And there's what I was trying to explain to you regarding, you know, tapping in. They're adding the cold water, or, you know, I don't know. And then they somehow get steam, but that's a plan. So some advantages to geothermal energy: very efficient. How efficient was it, guys?
So
they said it.
about 250 times more efficient than oil and natural gas fires, and 1% of the world's electricity provided from geothermal energy is equivalent to that on the board in the world.
So there's accessible sites, okay, because we know this. The problem is what you tap into and where you could get the electricity to provide for your homes requires large pipes. And that's, even though that's not on here, please add that, because I know you guys said it, and it's definitely a disadvantage. You need a lot of piping systems to get, you know, this energy transferred to where you need it to go. Always, it's going to be expensive to start. There is some toxic emissions as well as CO2 emissions, and the toxic emissions can be very harmful and can leak into the land. And there's also a lot of sulfur, not a lot, but there's sulfur involved. And again, high cost initially, but in the end, it definitely balances out. So everything is initial cost, and if there was some kind of governmental help, it would be like a trade-off, I guess. And this is another advantages and disadvantages. So even though I mentioned there's CO2 emissions, if you look at this chart, it's less CO2 emissions